Sorry. sorry. my phone went off.
Kama ulikuwa nakula.
Let us just proceed. Hey, Paul. So who was the admin? The host? Huh?
Yeah. Dean.
Oh, Dean was the admin.
Aziz.
Aya. Let us now proceed. You can now mute yourself. So we were asking which substances undergo sublimation.
We have
Aluminium chloride.
Aluminium chloride, correct?
ice.
Huh?
Dry ice or
Yes, dry ice.
Benzoic acid.
Benzoic acid.
And
Cynthia, correct. You have said benzoic acid. And many others. We will reach there. Don't be worried. Let us just go Yes, let us just go step by step. There is a certain word here, saturated solution. Saturated solution. What is a saturated solution? Yes, Mercy? Yes, Dean?
Mwalimu.
Yes, Shaban? Mesha?
Okay, a saturated solution.
Yes.
Is a solution that cannot dissolve any more solute.
Yes.
At any given temperature.
Very good. Another person, Dean? No, we don't have Dean and Shaban. Mercy and also Camila. Is Camila in class?
A solution that cannot dissolve any more solute at any given temperature.
Yes. So saturated solution is a solution that cannot dissolve any more solute at a given temperature. Are we together? So it is a solution that cannot dissolve any more solute at a given temperature.
Temperature.
Yes. Crystallization. What is crystallization?
The process.
Yes.
The process of obtaining. The process of obtaining crystal in a saturated solution.
Hey, you have wrapped. Try again. Make the class lively. Barasa. Let me see these people all because some are sleeping in class.
Process of obtaining crystals from a saturated solution.
Yeah, so it is the process of obtaining crystals from a saturated solution. For example, yes. So for example, when we have the solution of copper 2 sulfate, we can obtain the crystals of copper crystals from a solution of copper 2 sulfate. The process that we can use is that saturated crystallization. So we will obtain them. Yes? Is somebody speaking?
No.
Yes, so I'm saying you can obtain the crystals of copper 2 sulfate from a solution of copper 2 sulfate through this process called crystallization. Also, we can also obtain salt from a salt solution or from salty water. So the process, this crystallization also will help us to obtain salt crystals from salty water, obtaining sugar crystals from sugar cane, obtaining medicine from medicinate plants, such like things. So you should be able to know the application of the crystallization. So what is a crystal? So a crystal is a solid with definite regular shape. So they have a pattern shape. They have a pattern shape. That is what the definite regular shape. You have seen that. Now state and explain two types. Sorry?
Mwalimu, I have a question.
Ask.
Under the definition of sublimation, can we say that it is the process by which a substance changes from solid to vapor?
Yes, you can do that. Vapor and gas is the same.
Okay.
So, and the inverse, and the process by which gas or vapor changes directly to solid, which process is that?
Deposition.
Yes, deposition. Very good. You are a metal. State and explain two types of mixture. We have two types of mixtures. We have homogeneous mixture. If you understand by the, what do you understand by the term homogeneous?
And heterogeneous.
Yes, and heterogeneous. Homogeneous means they form one layer. It is a uniform mixture where there is no different layer. It is only one layer that is formed between the mixture of the solution maybe that you have. So it's a mixture with uniform composition and properties throughout its mass. And now heterogeneous is now the opposite. It is a mixture without uniform composition throughout its mass. Now define the following terms as used in the mixture. Residue. Now it is residues are now the solid that remains on the filter paper during the filtration. So when you are filtering, now you are separating immiscible solid to a mixture of solid and liquid. So when you are separating them, so the solid particles will remain on the filter paper. So those solid particles are what we call the residue, and the liquid that will pass through the filter paper is now what we refer to as filtrate. You can see filtrate is a liquid that passes the filter paper during filtration. We have the solute. Solute. A solute is a solid that dissolves in a particular liquid. For example, sugar can dissolve when you have sugar and water and you pour sugar into water, then you stir, sugar will dissolve in water. So the sugar is now the solute. So solute is a solid substance that dissolves in a given liquid. Then we have also solvent. Now the solvent will be now water in that our scenario where we had water and sugar. So solvent is the liquid in which a solid dissolves in. So you should know that one. Now I know I didn't include this. Then solution. Who can give us define the term solution? Solution. Cynthia? Mercy? Is Mercy in class?
Mwalimu.
Yes?
Mwalimu.
Yes.
Cynthia is asking you to repeat the question.
Yes, she's asking that.
Okay. Okay. Wengine wanakula hawaelewi chenye mwalimu anasema. Okay. Define the term solution. That is what I asked. Then you look like somebody who is Googling.
No, mwalimu. No.
That your posture of sitting.
Mwalimu, Cynthia has answered in the chats.
Oh, let me see the charts here. Pardon. Repeat the question. It is a mix of a solid and solvent, I guess. Don't guess. Try.
Don't guess.
Yes, Mercy. Try. For example, let me just give you a clue. When we mix solid, maybe sugar and water, we will get a solution of sugar. Sugar solution. So what is now this solution? Cynthia have tried and she's just correct. So a solution is a resultant that is formed when a solute dissolves in solvent. So when solvent dissolves the solute, they form what you call a solution. So you should be able to know that. Hi, let's continue. Miscible liquids. Who can define for us miscible liquids? I can see the chat.
Mwalimu,
Uh-huh.
Cynthia has answered, and also I want to try.
Okay, I tried the liquid that mix. Tried in.
Miscible liquids are liquids which mix to form a homogeneous mixture.
That is very correct. So you have to include those liquids must be completely mixed together, forming one layer. So if you don't want to use one layer homogeneous, you can use that uniform layer. So liquids that can mix together completely, forming what? One layer. Now the immiscible now is the opposite of that. What is now, who can define for us miscible liquids? So the miscible liquids are liquids that cannot mix together, completely forming one layer. Higher. State 3 physical means that can be used to separate a mixture. 3 physical means that can be used to separate a mixture. 1.
Filtering.
Filtering or filtration, very good.
Sieving.
Sieving, correct.
decantation,
decantation, correct.
winnowing,
Winnowing, correct. When we have only one person. Mercy.
Magnet.
Use of magnet, correct. Jane, Kinale girls, you have been so quiet. And also, now let's check these ones. So we have winnowing, the one that you've said. We have sieving, we have filtering, we have evaporating, decanting, and use of a magnet. So those are the physical.
magnet.
Physical.
Mwalimu,
Eh?
a question.
Ask.
A question.
Uh-huh.
Can we also talk of crystallization?
Sorry?
Can you also talk of crystallization?
Crystallization. No. We cannot talk about that. So what is crystallization? Is it a method of separation? Yes, it is. But is it a physical method of separating mixtures? The reason why then we cannot talk about crystallization. Crystallization is not the method of separation actually, but is now the process of obtaining crystals from a saturated solution. So if you get that the solution is not a mixture, for example, if we talk about copper 2 sulfate dissolving in water, that is a one solution. So it cannot be a method of separation that can be used physically to obtain the mixture. Are we together? Or you are not
Yes,
satisfied?
Malim.
Huh?
I'm satisfied. I'm satisfied.
Haya, wenye wako na simu weka simu kando. Messages zinaingia ni sawa tu. Haya, study the setup shown below and answer the questions that follow. We have A, we have B, we have C, D, E, F, G. So A is the beaker, you can see that. Then B is now the glass roll, this one, that prevent this beaker from leaning on this filter funnel. Then we have this C. C is now the filter funnel. Then we have this D. D is now the filter paper, which is placed inside the filter funnel. Then also E. E is now the conical flask. Conical flask. Then this F is now the filtrate. So we had defined filtrate earlier, so you know what a filtrate is. The filtrate is now that liquid that passes through the filter paper. Then now we have the G. This G is now the filtrate. No, the residue, I mean the residue, the one that cannot pass, the one that is retained on the filter paper. You should be able to know that. Then this is now the mixture of water and sand. Now the question which is there below that, Which method of separation is this?
Filtration.
The filtration. Very good. Very, very good. Then another question. Why is it possible to separate the above mixture using the method named above, the method that you have named? Why do you think it is possible to do so, to separate the above mixture using the above method? The method is filtration.
This is because a solution is not formed.
Because?
So a solution is not formed.
Not really, but you have tried. Jane. Cynthia, Mercy, Kusu, Timmy, Shaban, we need the answer.
I think it's different in the
Huh? Mercy, you have just scoffed. I've not heard whatever you have said. Shaban anakuja na fujo. Haya, tuambie Shaban.
I think because the mixture is not homogeneous.
Oh, that is a good. So let us check this one. Filtration. First of all, filtration is used to separate the immiscible solid to liquid mixture. That is what you have to know. Filtration. We cannot use filtration in separating two liquids at a liquid to liquid mixture. It is used in separating immiscible solid to liquid mixture. So that is what you have to say. So you have to say that it is possible to separate the liquid because the liquid, this mixture, because it is immiscible solid to liquid mixture. That is what you ought to have said. Let's see what I said here. Because it is immiscible, solid to liquid mixture. That is why we can separate it. That is the reason why we can separate the two. State suitable method that can be used to separate the following mixtures. The following mixtures. The following mixtures. Hey, bwana, umeanza tena? Mwambie uko class. Let me share another one here. That one will not help us now. Let's see this one now. Are you able to see the screen?
yes.
So this one is not arranged well the way we arranged the other. I can see Mr. Mai want to learn chemistry. It's okay, mwalimu. Wewe njoo tu. Tutapambana tu hivyo hivyo. Haya. The suitable method that can be used to separate the following mixture, ethanol and water. Kwani kitu I cannot hide.
Fractional distillation.
Which one was there again? I don't want to go here. I know people are just waiting to see. Standard paraffin.
Filtration.
Very
Filtration.
good. Very good. Standard aluminum chloride. Hapa watu wanakimbia.
Sublimation.
No.
Very good. Sublimation. Why?
Because aluminum chloride has the
Aluminum
ability
chloride
to sublime.
Yes, aluminum chloride sublimes. Oil from nuts and seeds. Oil from nuts and seeds. Hey, Mr. Maya,
Yes.
my student does not know how to separate the method that can be used to separate
Solvent
oil from
extraction.
nuts and seeds. Yes, Dean?
Solvent extraction.
Very good.
Solvent extraction.
Solvent extraction. In anywhere
Yeah.
you
So solvent extraction.
very good.
Complicated.
So what you have to know when you hear the word nut and seed, no, what should come to your mind is this name, the solvent extraction. Because oil, they can ask you also to how to obtain paraffin from crude oil. Paraffin from crude oil, who can tell us the answer?
Paraffin from crude oil.
Hey,
Fractional distillation.
Fractional
yes,
distillation.
fractional
Indicators.
distillation. Iron and sulfur. Sasa hii mwenye hajaongea class.
Use of magnet.
Use of magnet.
Use of magnet because iron can be attracted by a magnet. Very good. That is magnetic. Alright, let's continue. Let me see. This is red and blue coloring pigments.
Mwalimu, hiyo ni paper chromatography.
Asante sana mwalimu. So the red.
Mwalimu, I think maybe Mwalimu is either Googling or reading a
No.
textbook there.
I know these things.
Uh,
I know these things. I did chemistry. I did three sciences.
Ogenya girls. There is somebody from Ogenya girls. Hiyo sijui iko wapi. Aya, the pigments. If you hear the word the pigment, Mercy, we talk about the
Chromatography.
not chromatogram. Chromatogram is now the paper, but the method of separation is chromatography.
Graphy.
Yes. Very magnetic. Aya, sodium chloride and water. Sasa hii nimepeana.
Evaporation. Simple distillation.
So we can use even evaporation, but the best one is simple distillation. Simple distillation. So let us see what I wrote there. The most suitable one is simple distillation. But if you write evaporation, you will be given. But if you see such a question, write simple distillation.
Mwalimu,
Yes,
what if I just say distillation?
you will be wrong.
Oh, what is the
Yes.
difference between distillation and a simple distillation?
No, we have two types of distillations, Mwalimu. We have a fractional distillation, where fractional distillation is used to separate miscible liquids with different but close boiling points, like ethanol and water. Then simple distillation is used to separate miscible solid to liquid mixture with miscible solid to liquid mixture with high different range, a wide range of boiling points.
Okay, thank you.
But simple distillation is for miscible solid to liquid mixture.
Okay.
While fractional is from the miscible liquid, which have close but different boiling points.
Okay.
Explain how you will obtain pure ammonium chloride from a mixture of lead sulfate and ammonium chloride.
screen now, you would obtain pure ammonia chloride. Very simple.
Hapa ndio wanafunzi huwa wanaona balaa. Tumefika kwa chemistry sasa.
Mwalimu,
Yes, Leslie. Leslie, speak.
How to separate how to obtain a pure sample of ammonium chloride. We heat the solution of lead sulfate and ammonium chloride, and since ammonium chloride is a sublimate,
It is not a solution.
Oh, we heat the mixture, sorry.
Now continue, explain, yes.
So we heat the mixture of ammonium chloride and lead sulfate. Then we obtain ammonium chloride as a sublimate since it sublimes. Then lead sulfate will remain since it is an insoluble solution. So yeah, we'll obtain ammonium chloride as a sublimate.
So when you are answering such a question, you ignore the word solution because you have not been told any, we don't have any solution here, unless if you want to add water. So here you have to, before you separate the mixture, know their properties. When we were defining the mixture, we say that the mixture is a combination of two or more compounds in which each mixture retains their physical and chemical properties. So study their physical and chemical properties. Like here, we know ammonium chloride. Ammonium chloride is a substance that undergoes sublimation. Lead sulfate. Lead sulfate is a solid. And we know that lead sulfate, what do you know about lead sulfate? Is it soluble or insoluble?
Yes.
Is sulfate soluble or insoluble?
Mwalimu.
Eh?
It is insoluble, but I have a suggestion. I think you should be looking at the charts so that, because Cynthia is answering those questions.
You know, I'm working from Nigeria. Unaona mimi hata siko huku Mombasa. Unaona
Mwalimu, you are not seeing your face. Mwalimu, you are not seeing your face.
You are not seeing my face.
Yes.
Are you not
working from Nigeria?
No. We work from home.
Nasema hivyo. Amesema hivyo. Tunaenda tu meza ya chakula.
Haya. Okay. Tuangalie hii. We were checking I said when you want to separate the mixtures, study their properties, both chemical and physical properties. Where we have said here ammonium chloride sublime. So what do? You put the mixture in a beaker, then you heat. The ammonium chloride will sublime, and it will be collected at the cooler part of, maybe if you are using the beaker, at the cooler part of the beaker. So you will scrub them after heating. Then you will remain with lead sulfate. So that is what you have to understand. So place the mixture into a beaker and cover with a watch glass containing cold water. So this watch glass, this cold water will now cool the vapor of the ammonium chloride. So heat the mixture gently. Heat the mixture gently. Ammonium chloride will undergo thermal dissociation to form ammonia and hydrogen chloride. Ammonia and hydrogen chloride will combine to form ammonium chloride, which is then collected at the cooler part of the watch glass. So you should know that. So what will remain is now the lead sulfate. Any question? Shaban.
Yes, Mwalimu. What if you talk of, instead of saying ammonium chloride will undergo thermal dissociation, can you also say ammonium chloride will undergo thermal decomposition?
What? Yes, it decomposes. It decomposes to ammonia and hydrogen chloride.
Okay.
Anything that is being heated, it decomposes. Like if we talk about maybe in the preparation of nitrogen gas, where how can we obtain nitrogen gas? You know that you were taught recently. Also, we can also get oxygen gas by thermal decomposition of potassium manganese 7. Potassium manganese 7. When we heat it, it decomposes. It decomposes to those other elements that you should know at the moment. Let's see the next question here. How can you separate a mixture of sodium chloride? So sodium chloride is contaminated with copper 2 oxide. Explain how pure sodium chloride can be obtained from the mixture. Yes. Mercy. Yes. How can you separate a mixture of sodium chloride and copper 2 oxide? Somebody is typing, I can hear the sound. Wait, guys, how can you separate? Yes. Leslie. Leslie, speak.
To separate a solution of sodium chloride and copper 2 oxide,
It is
first
not,
we heat copper
first
2
of all,
oxide.
sorry. It is not a solution. We have sodium chloride itself and also we have copper 2 oxide.
I'm sorry, it's a mixture. So to separate a mixture of sodium chloride and copper 2 oxide, we first we filter the mixture, since sodium chloride is soluble in water and copper 2 oxide is not soluble in water. Then after filtering the mixture, I think we can evaporate the filtrate, which is sodium chloride, and the residue is copper 2 oxide. So we evaporate the filtrate, then we wash the sodium chloride crystals, then we dry between filter papers to obtain dry sodium chloride.
Okay, you have tried. So that is very good. So what you have to say here, these things are solid. Study their properties, sodium chloride and copper 2 oxide. Sodium chloride can dissolve in water. Yes, somebody is raising the hand. You are two people. So who is that? Speak. Okay.
Yes, Mwalim.
Yeah.
How to separate contaminated sodium chloride and copper 2 oxide?
Hey.
First, I think you should add water to the mixture.
That is very correct.
Yes, after adding water, then you heat
Yes.
You heat the mixture.
Yes.
Then after heating that mixture, you ensure that after it has, first before you heat, you filter it.
Yes.
Yeah, after filtering, you heat that filtrate.
Yes.
Then I think the sodium chloride will evaporate or dry.
Yeah.
Then you could have obtained it that way.
Sodium chloride evaporate itaenda wapi? Sodium chloride does
No,
it? Okay, now let us demystify this. Sodium chloride dissolves in water. That is what you have to know. Copper 2 oxide is a solid that does not dissolve in water. So what do you add water to the mixture? That is first step. The second step, filter. Filter to obtain sodium chloride as a filtrate and copper 2 oxide as a residue. So to be now, copper 2 oxide will now remain on the filter paper. We shall have separated copper 2 oxide. Tumeweka kando. Tumebaki na solution of sodium chloride. It is not sodium chloride, but it is a solution of sodium chloride. So what you do, you evaporate, you heat the solution to evaporation. Then you can now you heat the mixture to the dryness. You evaporate it to dryness so that you can remain with sodium chloride crystals. So let's check what I gave here. Sorry. Add water to the mixture, stir and filter to obtain copper 2 oxide as a residue. Evaporate the filtrate to dryness to recover. Sorry, don't answer that message. Evaporate the filtrate to dryness to recover the sodium chloride crystals. So that is what you do. So the first thing, add water to the mixture, stir and filter to obtain copper 2 oxide as a residue. Evaporate the filtrate to dryness to recover the sodium chloride crystals. Any question up to there?
No.
Haya, let's continue. The diagram below shows the relationship between the physical states of matter. Study it and answer the questions that follow. So I know the first question here, you name these processes. So name the processes R, V, U, W, and X. So who can tell us R? Process R.
Melting.
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 That is solid to liquid. Very good. That is melting. V.
Evaporation.
Evaporation.
Yes, liquid to gas evaporation. W. U. Sorry, U.
Freezing.
Liquid to
Condensation.
solid.
Condensation.
It is
Freezing. Freezing.
Freezing.
freezing. So that is liquid to solid is freezing. That is cooling.
Freezing.
You cool it beyond the sea level. Take this W.
Condensation.
Condensation. X.
Deposition.
Deposition.
Sublimation.
Deposition.
Deposition.
Naona watu wanasukumana. Ni vizuri. So X is a deposition. That is gas to solid is a deposition. Then solid to S, solid to gas.
Sublimation.
Yes, that is now the sublimation. Now let's check the answers. So we have melting, evaporation, which is also known as vaporization.
Vaporization.
We have also freezing, which is also known as
Solidification.
Solidification.
Very good. Condensation and sorry. Then we have condensation. Nilikuwa naambia mtoto aende alale. Then also we have deposition. So I came up with this formula. You can check it. We have sommelier colipresso is a mnemonic for physical changes of matter. So that is a mnemonic. You can use it to master the processes for those. That is sommelier colipresso. So solid to liquid is melting. Then we have liquid to gas is evaporations. Then we have gas to liquid is condensation. Then we have liquid to solid is freezing. Have we check out that mnemonic work?
Yes.
Yes, that is very good. Name two substances. I hope you have seen how this works. So solid to liquid is melting. So you skip the red one. So the red one, between the black one and the black one, the middle is now the physical changes, the physical change. That is solid, liquid is melting, liquid gas is evaporation, gas liquid is condensation, liquid solid is freezing. So that is it. That is sommelier colipresso. Then we have name two substances which can undergo the process represented by S and X. Yes. Who is that typing? So the process, we have talked about the process X and S and X, that is sublimation and deposition. Mercy, give us the substances that can undergo the process S and X.
Dry ice, iodine, benzoic acid.
Yeah. I know you have just seen the one, people have just seen the three that have displayed. Now say the rest. Dean?
We have anhydrous ion 3 chloride. We have carbon dioxide, which is dry ice, and the I think it is
Aluminum
ammonium
chloride.
Yes, somebody also is raising the hand. Just answer, please.
Ammonium chloride.
Ammonium chloride, correct. Another one, we have the camphor. Are we together? Camphor also undergoes sublimation. We have anhydrous aluminum chloride. We have anhydrous ion 2 chloride. Are we together?
Yes.
Now let us check them here. We have all these one. We have the camphor aluminum chloride. We have ammonium chloride, anhydrous ion 2 chloride. And now check what I've written just beside it. The process S is a sublimation. So it's a mnemonic for substances that undergo sublimation. That is Badika. So if you master the word Badika, will help you to master these substances that undergoes sublimation. Badika. Yule Badika ni mnoma jo. You should be able to do that. Sasa
Mwalimu pardon.
Okay, so B will now stand for benzoic acid, then A is aluminum chloride, then D is dry ice, then C is camphor, then A is anhydrous iron 2 chloride. Note, this is what you have to know as a student. Avoid aluminum chloride. You are now a form 4. So avoid aluminum chloride, ammonium chloride, iron 2 chloride when answering questions on substances that undergo sublimation in exam. Are we together? So you can just talk in exam, kindly talk about the benzoic acid, dry ice, camphor, full stop. Yes, Leslie. Leslie.
Sorry, I had not lowered my hand.
Okay, Dean.
Mwalimu, a question.
Yes.
Is it anhydrous ion 2 chloride or 3?
Anhydrous ion 3 chloride. Yes, ion 3.
Yes.
Yes. Ion 3. So know that. So that is the formula. From today, you know the formula. You will never miss that in an exam. When it now comes to you, that is badika, yule badika, badi yako ni mnoma, you should know that. Kama uko na badi, ni sawa tu. Lakini, there is no problem. Now, yeah, let us check this one. A very, very good question. So now you can see the setup below represent apparatus that may be used to separate a mixture of two miscible liquids CD, whose boiling points are 80 degrees Celsius and 110 degrees Celsius respectively. Name the method of separation. So how will you come to this method of simple distillation? Why do you think we are coming to this one? Simple distillation. One, you check this one. Simple distillation, there is no fractionating column. Know that. In simple distillation, there is no glass beads. So that is how to identify whether the apparatus, the mixture is being separated using simple distillation or fractional distillation. Yes, Dean.
So, Mwalimu, that means that in simple distillation, we have to use a Liebig condenser.
No, I'm saying, how can we know that this is, here we have two distillations. We have fractional and simple distillation. So what will give you the answer? Know that in fractional distillation, we have things like a thermometer. We have things like fractionating column. We have the glass beads, which is not here. Are we together? It is not here. So what will we go for? The simple distillation. The simple distillation, we don't have fractionating column. We don't have glass beads. Am I clear there? Then you also go back to the boiling points of the liquids that you are given. Check their boiling points. Are they close to each other? They are not. They are widely apart. Because in simple distillation, we separate the liquid or the mixture with wide range of the temperature. You should know that. Is there any question?
No.
So I hope I'm very clear. So when you were given such a question, it was set in the year 2015. Kindly go and revise that paper. 2015, you will get it there. Now check this one. You will, if you are given this, it's such a diagram, study it carefully before you rush to your answer, as if you are going to, ulikuwa umebanwa, ulikuwa unaenda chooni, sasa hujui ufanye nini. So you have to study it carefully. You have to study this carefully. Ni sawa. So you check what is missing. What is missing here is what will give you the answer. Otherwise, let's see, there's name A and B. A is what has been collected here. The one which will be collected first. Shaban, don't chat. I know you are chatting with somebody. Check this one. The one that is collected here first is the one with the lowest boiling point. The one with the lowest boiling point. C and D, which one has the lower boiling point?
C.
C. So to mean this A will be liquid, this C, which is now the distillate. This is now the distillate. Then we have part B. Part B, who can give us the answer for this part B?
Part B, Liebig condenser.
Liebig is condenser. Liebig is condenser. So what is the function of this Liebig is condenser?
Pardon?
What is the function of this part B?
Mwalimu,
Uh-huh.
it is used to condense the vapor of liquid whose boiling point has been reached.
What you are referring in is a fractionating column.
It is
Whose boiling point has been reached.
Yes, that is what you are referring to, the function of the fractionating column.
Fractionating column.
Leslie?
the Liebig's condenser is used to improve the condensation process.
Not really, but you have tried. Messages zinaingia kuingia. Aya, let me now remove you from the den of lion. So this part B is the Liebig's condenser. The Liebig's condenser is used to cool the vapor efficiently. Are we together? It is used for cooling the vapor. Why do you say so? There is cold water entering through this process. So that cold water is what will be used to cool the vapor. After, because this warm water will absorb some heat from the vapor, and now they will go out as warm water. So you should see that. And what will happen when we interchange the water outlet and water inlet? Yes, Dean.
Mwalimu, me have not agreed with you and Shaban. Mwalimu, the function of the Liebig condenser is to condense the vapor of liquid whose boiling point has been reached. For the fractionating column, it is condense the vapor of boiling point of condense the vapor of liquid whose boiling point has not been reached.
Aya, let me give you a verse. The Bible is chemistry book 1. Go to page I think it is in page let's see, I'm not wrong and I'll never be wrong in chemistry. Go to page 31, page 31, the first paragraph, the statement after the second decimal full stop, and I'll read. The purpose of the fractionating column is to allow water vapor to condense into liquid and flow back into the flask before the boiling point of water is reached.
Yeah, Mwalimu, that's what I've said. It has no difference. I've just said now that it condenses the vapor of liquid whose boiling point has not yet been reached. For your instance now, for the water, it was not yet reached, so it had to be condensed back to the flask. That's what I said, Mwalimu. And as for the Lebesgue condenser, it condenses now the one which has been reached. The boiling point has been reached.
What is condensation?
It is the process of changing gas into liquid.
So what is the difference between cooling and condensation?
None.
Huh?
It has no difference.
In the same book, I'm here to help you out, Dean. The same book, let me see whether we are talking about that. Liebig condenser is used to cool the vapor. The Liebig condenser uses the counterflow principle to cool the vapor efficiently. It uses the counterflow. The counterflow means there is one getting in and the other one getting out. Yes. Leslie? Two people raising the hand. Dean, you are raising your hand. Leslie, you are raising your hand.
I had. You had asked the function of the Liebig condenser.
Yes.
And I'm also referring to your Bible, page 27.
Page 26.
27.
Page 27.
Yes, of the Bible.
Yes.
The very last line on that page.
Yes, the 27, eh?
Yes, it says to improve the condensation process, a Liebig condenser is used. Meaning, if we interchange the words, it says a Liebig condenser is used to improve the condensation process. Now, what is your answer and where are you referring it from?
Why am I referring which answer wrong?
You had said that my answer is wrong.
Okay, what is your answer? Now speak. I get speak clear so that I can get whatever you're saying. I'm here to get you out of the darkness.
My answer is that a Liebig condenser is used to improve the condensation process.
Is used to improve the condensation process. So what is the condensation?
See, we say that condensation is the change of state from a gas to a liquid.
Gas, to mean gas is warm rather than hot.
Oh yeah.
Yes, to mean what will take place there? What will take place inside here? Cooling. So yes, that is, it will cool this. There is a vapor which will come here, then that vapor will be cooled, and it will be turned to liquid, and that is why you can see it has flown inside this beaker which is here. So the function of this one, even if you say it is used as it condenses the vapor, that is very correct.
Okay, thank you.
Yes, also it cools the vapor. Correct. The vapor of the first liquid which will pass through this process, the one that its boiling point shall have reached first.
Yes.
So what will happen when we interchange the water outlet and water inlet?
Condensation will still occur, but less efficient.
Yes, that is very true. That is now in page 30.
Mwalimu.
Uh-huh.
So are you agreeing with my answer?
What is your answer, Bwana Dean?
For the function of the Liebig condenser.
Yes. Okay,
See,
let me now tell you, Dean, what will be marked here. We will mark when you use the word condensation of the vapor. The word condensation of the vapor. Condensation is just the same as cooling, because the vapor is being cooled to what? To liquid, to form liquid. Okay. And somebody you will say to cool the vapor. That person also is correct. But how I wish you could have added the word efficiently. So it cools or condense the vapor efficiently. So that word has good weight. Then speak. Okay, what's your answer? You know, we are arguing and I've not heard your answer. So can you speak so that I can hear it once more?
Okay, Mwalimu. I used to read Miranda's High Notes and Starehe Boys also notes, and they keep putting out my point that the function of a Liebig condenser is to condense the vapor of liquid whose boiling point has been reached. And as for the fractionating column, even if it is not here, it condenses vapor of liquid whose boiling point has not yet been reached. Even we can take, for example, now, let's say we are doing the fractional distillation of ethanol and water. We know that ethanol will distill off fast, right? So,
Then you are correct. Don't go much into details. Because at first I thought you were saying to cool the vapor of which its boiling point has not been reached. But now if you are saying the one that the boiling point reaches first, that is very correct. Because the one which its boiling reaches first is the one which will be collected as the first distillate. To mean as it will be passing through this Liebig's condenser, it will be cooled and condensed into liquid. Sawa sawa, you are correct. Mimi nilikuwa nadhani ulikuwa unasema yenye boiling point yake ijafika. So that is why I was referring you that is the function of the fractionating column.
Okay, Mwalimu.
Hey.
Thanks.
What is the purpose of the thermometer? This thermometer.
Record the temperature.
Yes, it is used to record the temperature. How would a pure sample of the distillate be obtained? How can you obtain the pure ones? Now you will use carry what is called redistillation. You will redistill the mixture. After obtaining this distillate, you redistillate it again for you to get the pure one. Which liquid was collected first? We have said that the one with the lower boiling point. The one with the lower boiling point, that is C. This one in the what is the time? Kwani kitu haina limit? I have only 5 minutes. Then I'm sleeping. In the process of extracting oil from a castor oil seeds, in the laboratory, Zainab first crushed the seeds and then added propanol instead of water, and later left the solution in the sun. Now the first question. So the question that can be asked here first, why was the seed crushed? Who can give me the answer? Why was the seed crushed. You should know that. Another question that can be asked here, why did the designer just add propanol, not water? And why was the mixer left in the sun? You should know that. So let us begin. Why was the seed first crushed? Yes, Dean.
The seed was crushed to increase the surface area of contact with the solvent.
That is very correct. So the seed, anywhere where you get a question asking why something was crushed, it was crushed to increase the surface area. That is also applied. You can check in the preparation of hydrogen gas. We are using granulated zinc. Granulated. Why just not a metal of zinc? It is granulated. To me, the granulated is now it has been granulated into smaller particles to increase the surface for the contact of the acid, that is the dilute hydrochloric acid or sulfuric acid. So here also it was crushed to increase the surface area for the contact of the solvent, which is a propanol in this our case. Why was propanol added instead of water? I can see this person to dissolve the oil. Okay, another person also can try with another answer. Yes, Dean.
Mwalimu, let Leslie answer first.
Where is that? I cannot see her. Able speak, Leslie.
Propanol.
Unmute yourself. Umeenda. Another person. Leslie. I have only 3 minutes. I'm tired. Hii meeting haina limit.
I'm a trial. So the water is not used because it does not dissolve oil, whereas propanol can.
Okay, so we use propanol because it can dissolve the oil, but not water because water cannot dissolve the oil. Why was the mixer left in the sun? Mtu ana type ama huyo anafanya nini? Kushu speak. Huh? Aya. Didn't give us the answer.
It is left in the sun to allow the solvent to evaporate.
Yes, it is left in the sun for the solvent to evaporate. To explain why the seed was first crushed to increase the surface area in contact with the solvent. Explain why the propanol was used, not water, because the propanol dissolves oil while water does not. Explain why the solution was left in the sun for the solvent to evaporate. I want to leave from there, or should we tackle this one, then we leave it from there? Yes, should we do this, then we leave? Or we leave from there? Let us end it from there. Let's begin it from the next day. It is a very good book, by the way. If you can purchase it, it is well and good. It can really help you during revision. Any question before? Yes, Dean?
Mwalimu, my question does not concern the lesson of today.
There is no problem.
Mwalimu, in the group you said that you have a YouTube channel. What's the name?
The name is The Brilliant Publishers. You can use that video in Letuma. It will take you to the YouTube.
Okay.
Also, you can also visit our website. You learn from also there. I'm really working on it. It is a very good website where you will get the question papers, the cases with their marking schemes, all the term to all exams. But you have to subscribe.
Okay.
Sir, can I ask you something?
Yes, ask me.
So there is a group.
Yes, there is a group for discussion. Those siku hizi watu hawaulizi swali. Even if I ask the question, it can take 3 days.
Can you send the link?
Yes. Is there any way somebody you can text me through 07? Let me give you the number so that you can copy it from there. I don't know the number of head.
11 41 05 83.
There is somebody has mastered my number, yet me, I don't know my number. Let me share with you so that you can see. So mimi niliacha kutuma questions because it takes 3 days before the question is answered. So hope you can see the number. That is the number. Somebody is rubbing it. Ni sawa tu. Hata ukifunika imerudi tu. Sasa we should be aggressive. Funika tu haina shida.
It's 07
I've sent the link.
Oh, you have set the link?
Yes.
Yes, I can see the link. Join the WhatsApp. Yes, there we discuss chemistry as nobody's business. I usually set the questions there at saa 7 usiku. I know even the parents are wondering, but that is the kind of the person I am. I do make noise in the group with the good things. So the people who take them serious, we will sail together so that we work. Cynthia, questions ziko kwa group. Ni sawa tu. Let us end it together. May God bless you for attending the lesson. Let us meet tomorrow. Tomorrow, I think I'll have chemistry form 2 that is under structure and bonding. So look for me any hard question that you think, then we will discuss it. It's a very crucial topic that you should not miss, though it is for form 2s. Otherwise, goodbye. Mnangoja niache alafu mwanze kustory hapa. Kila mtu aende alale.
Mwalimu, the host should first leave the meeting, then we follow.
Tuna end wenyewe.
You can leave. Asitaki kuacha. I don't want to leave you here. You go and sleep.
Mwalimu, we are following you. You can just leave first, then us will follow later.
Okay, maybe I'm ending, not leaving.
Mwalimu, you just leave only. Don't end.
Mimi nimeenda.
Good night.
Good night to puonjo petek nyasachiel aul. Wanindi kiny an gi lesson. Kata buk nandiko kapok atieko ndiko koro.
Thank you for the lesson.
Welcome.
Sasa wewe namkombe ujibu.
Talale.
Mwalimu, thank you for the lesson.